On this channel, I often talk about the notion of detecting alien civilizations through SETI and various efforts looking for biosignatures. So far, nothing convincing has come back, and the universe presents only the great silence, with only the occasional unverifiable blip that may suggest otherwise, such as the wow signal. But a lot of these kinds of efforts make a certain assumption that aliens know about us and wish to contact us or at least study us. This is actually somewhat of a problem, however, in that it may actually be extremely difficult for them to know that we're even here. You see, not only is it harder than you might think to detect our technology, it's actually extremely difficult to even detect Earth itself from a serious distance. But that in itself makes a certain assumption. Can intelligent aliens detect anything outside of their own world? That's not guaranteed. We have always gazed at the heavens throughout our history and wondered what those tiny points of light in the night sky are. The question drove us to determine that they were stars, and now science works to gain a complete understanding of them. But would we have taken the same inquisitive route if we couldn't see the stars? What if the sky overhead at night were merely black, or obscured by an opaque atmosphere, or permanent day from multiple suns? Or worse, you live in an ocean permanently locked underneath a wall of ice, as perhaps is the condition at Europa if there is life there. Such an alien civilization may be intelligent, perhaps even more than we are, yet never know or be motivated to ever explore space, or even realize that it's there. Pragmatic things like survival may occupy more of their time. This was the case with us. For tens of thousands of years, humans focused on day-to-day survival. There was little time left for inventing smartphones 50,000 years ago. Rather, all time was dedicated to survival, raising children, and continuing existence, along with time for things like religion. But a certain series of inventions, from tools to pottery to agriculture, allowed us time to think about other things, and from that we built our civilization. But that's not guaranteed. If the wrong things happened, or indeed happen now, we could get reset. Maybe we are not the norm here, and intelligent alien civilizations never have the time to become a spacefaring civilization, or they get reset so much that they never become technological. Thus, they never reach a stage to even know to look. To ask a question, you must have a basis to formulate the question you want to answer. If you never get there, then you never get an answer. But once a civilization does get there, they enter a different boat, that of the challenges of astronomy. Detecting exoplanets is difficult. Look at human history. The first hominid that we can actually call Homo sapiens like ourselves appears about 200,000 years ago. Certainly they must have looked at the stars like we do and wondered, and that probably even predates Homo sapiens and extends to our progenitors. Early humans saw the planets as well and noticed that they moved and so on. But how long did it take us to discover the first exoplanet? It took until 1992, or approximately the entire 200,000-year history of our species. And the discovery of exoplanets was a mere trickle since 1992, until we devised instruments specifically intended to look for exoplanets. And today we know of thousands, and not a single one of them is a true twin of Earth. But that may not be a problem of there not being other Earths. Rather, Earth analogues are extremely hard to see with the instruments we currently have. This is getting better. We may be able to do things like characterize exoplanet atmospheres now that we have the James Webb Space Telescope coming online. But what if we hadn't built it? What if we didn't have our global array of huge ground-based telescopes? What if we were just a little less curious or occupied with other things? The answer is that we'd not be studying exoplanets at all, which means that alien civilizations may never find the time or resources to look into exoplanets. Just because we currently do it doesn't guarantee that it would have been done under other circumstances. So we build ever larger and more capable telescopes, and aliens may never do that. But if they do, they then face the problem of detection. Even if they had huge telescopes, much bigger than ours, then they'd need to know to even look at us. This is not as easy as it might seem. First involves a bias. Our sun is type G, but we also know that other types of main sequence stars could harbor life, specifically the red and orange dwarfs. So maybe they have a bias and only look at those types of stars for civilizations instead of our cranky and short-lived by comparison type G sun. But then, what if they do realize that type G stars can host civilizations? Well, to find us, you have to choose our sun to look at. Best estimates right now is that the sun is one of a population of 6 billion type G stars in the Milky Way galaxy currently. That's a whole lot of sun analogues to look through to spot Earth. But say they looked at them all and decided to take a close look at the sun. Would they see Earth? Not without a huge telescope, bigger than anything we currently have. And that's if they're close enough. Spotting exoplanets is extremely difficult, though they might see Earth transit the sun directly, but only if our planet transits in their line of sight. Spotting it directly is far less likely and much harder. Otherwise, the only thing they may know about Earth is that it's there through gravitationally perturbing the sun and making it wobble. And there's also the question of distance. The further you are from Earth, the harder it is to detect. So while you might see it if you were close, you might also be halfway across the galaxy and never know it was there. It could be too distant to reasonably see. As an aside though, even if close, they might not see a major feature of our planet, the moon. Exomoons are even harder to spot than Earth-like planets, meaning that an alien civilization studying us may never even know that we have a large moon. But distance also currently makes us impossible to see as a civilization. Our technological signals travel at the speed of light, and that means that our signals can physically only be detected at a distance of currently about 100 light years. But even then, the earliest signals humans have broadcast were very weak. The 1936 Berlin Olympics television broadcast that's popularly cited as the first things aliens might receive would not have made it out. And that wasn't the first television broadcast. And the radio at the time was many, many times more powerful, as in 500,000 watts for some stations. But at light years distance, not much of a chance to pick that up. What they might pick up, and again this shrinks the radius in which this can currently be detected, is our more powerful radar from World War II and later. Even more visible would be things like the former Arecibo radio telescope radaring asteroids, or sending out the famous Arecibo message, which would be very detectable if aliens happen to be looking just when it passes through. But all of these are transient. To pick any of it up, aliens would have to be looking right at us at exactly the right time. And even then, if they have SETI protocols like our own, they will discard the detection because none of them have repeated. Make no mistake, we may well have detected alien radio signals and discarded them because a one-off detection isn't enough to prove anything. So how do they know when to look right at us? Here, the playing field widens. It's Earth's biosphere that may tip them off to keep an eye on this world. Whereas we've only been broadcasting for about a century, Earth's biosphere has been broadcasting its existence for over 2 billion years. Ever since the appearance of photosynthesis, our world has maintained an atmosphere that is in chemical disequilibrium. Oxygen occurs naturally without biology, but this much oxygen, currently about 21% of the atmosphere, is pretty difficult to explain without biological processes creating the pronounced disequilibrium. Add in other biologically related gases such as methane and phosphine, and you have a growing case for a biosphere being present at this world that any civilization in the galaxy that has sufficient instrumentation to detect could very well know about this world if they have surveyed the entire galaxy in detail. Oddly, as an aside, Earth isn't the only planet in the solar system that presents an odd disequilibrium. that of late has been getting increasingly difficult to explain. It's Venus, and it too shows a small, unexplained chemical disequilibrium in its atmosphere, far less than Earth's, but adding another hint that there may be something microbial going on in the atmosphere of that world. We need much more data to determine that, but it's interesting to say the least. And then we come to another biosignature that could reveal something surprising in principle. The idea is the vegetative red edge, where Earth's plants become highly reflective in infrared, almost like mirrors due to the structure of their cells. This is something that scientists studying exoplanets will look for in the future, and it's something that in principle aliens might know about Earth. But here's the oddity. There's one thing humans have done far longer than radio that could possibly be detected, though it's very unlikely with Earth. But if an alien civilization were practicing very wide-scale agriculture, like covering their planet in agricultural fields, it's possible that signals within the red edge might indicate widespread harvesting or manipulation of their biosphere by a pre-industrial civilization. Given that humans have been practicing agriculture for at least 10,000 years, and recent work suggests far longer than that, then it does seem to be a very long-lived technosignature. That's if it could actually be gleaned out of any red edge measurements, which may prove a step too far. To detect such a thing with Earth would require the alien civilization to be very close, and this comes up against a statistical problem. Take Proxima Centauri, the closest star system to the Sun, that also has at least 2 planets orbiting it. If one of those planets has a civilization on one that happens to exist right at the same time we do, then that would imply that there are alien civilizations literally everywhere. After all, what are the chances that the closest star system to you also has a civilization? At that point, any habitable star system could have one. If that were the case, then we should readily see evidence of a plethora of civilizations, and we simply don't. Extending the sphere out to about 100 light years, as SETI currently favors, and we still so far haven't seen any close aliens. But that doesn't mean that there haven't been close aliens in the past. The galaxy is a tumultuous place, with stars constantly in motion. In the 4.6 billion year history of our solar system, the Sun has passed close by to countless other stars, most of which we cannot reconstruct or even know about these long past encounters. We do, however, know of more recent ones, and it could be that at some point in the past, the Sun passed close to an inhabited system. If that's the case, then close alien encounters become more plausible, and any civilization advanced enough to cross a few light years may have deposited probes in our system and studied Earth in the past, and possibly even continued to do so. This concept is known as a Benford probe, and presents one of the possible ways an alien civilization may study Earth close up, just by sheer luck of having passed by. It also opens up the even greater possibility that a passing inhabited star system encountering us further out might have studied Earth with their telescopes, but were too distant to feasibly visit. Perhaps they still watch us today. But say this was happening now, and there is another civilization within, say, 50 light years. Here's where we become significantly more visible, not just in our radar, but something that can be detected much more distantly. The signatures of chemicals in our atmosphere, such as CFCs, that do not easily occur in nature, if at all. But there's one final way where aliens could actually know about us. That's if they have colonized the galaxy in some form or another. This is the famous idea of self-replicating, self-repairing probes that spread across the galaxy, creating copies of themselves like a virus. In which case, in a few million years, a civilization could have a probe stationed in every star system in the galaxy. In this one situation, we would be known about and watched, and indeed all civilizations in the galaxy would be watched by these probes. There are 2 forms of this idea. active and passive probes. With passive probes, they are simply watchers that allow civilizations to develop on their own, and they simply observe for the sake of science and learning. With active ones, they may intervene for some reason and make direct contact. It may function as a 3D printer and create subordinate probes to explore the solar system, and perhaps even dip into Earth's atmosphere. Imagine if someone saw that. It's worth mentioning here that there has been one other form of communication that we've tried. Actual physical evidence of us in the form of our space probes bearing gold records and plaques. It's marginally possible, but extremely highly unlikely, that anyone will ever find those. They are beyond needles in the haystack, but rather needles in hay bales the size of Jupiter or more. Right now, some of them weakly transmit towards Earth still, but in a few years they will run out of energy and just drift as incredibly tiny dead flotsam in the interstellar medium, and will almost certainly never be found. So the solution to the Fermi paradox here is quite simply that aliens can't see us, and don't until we do something so huge in the far future that we become visible, such as encasing the sun in a Dyson swarm, or building a huge radio beacon. Maybe no one ever does that. And it could also be that we simply lack the instrumentation and ability to see the aliens, and that the whole detection of other civilizations is far more difficult than was previously imagined. So much so, they very well may not know of us. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently concerned about the first radio broadcast aliens might pick up. The Berlin Olympics were too weak, but later transmissions, just a few years later, were far more powerful. So what happens if the aliens pick up Orson Welles' production of The War of the Worlds and think we're under attack? They might show up with battle stars ready for a fight, only to find that we cried wolf. Very disturbing. And also, anyone that wants to hear me get interviewed for a change should check out a recent 3-hour conversation I had with Carson. Link in the description below, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.